All right, 29. So, guys, 29, we start off with all the tails of 16 to go over 3. So we have 1, 2, 4, 8, 16, all over 3, plus or minus. And we just start going. So we have, start with 1, we have 3, 11, 8, 44, and negative 16. No placeholders, everything's going to work out nicely. It's a matter of just dropping and going. So we have 3, 3, 14, 14, 22, 22. As you can see, it's not going to be working. Try negative 1. Same thing through. Was it negative 4?
Yeah.
I'm going to skip ahead to negative 4. Was it 3 work too? Or 1/3? Oh yeah, 1/3 works in this one too. So we wind up with 4, 12, negative 48, negative 4, 16, and a 0. So you wind up with a 0 at negative 4. Therefore, your term is x plus 4. And now I'm at a third-degree polynomial with 4 terms. I'm automatically going to check and see if I can group it. Checking to see if you can group is going to save you a boatload of time. Because lo and behold, I get GCFs, it's going to work. Take out the x squared, I get 3x minus 1. Take out the positive 4, and I have a 3x minus 1, which gives me my other 2 sets of terms as x squared plus 4 and 3x minus 1, which gives me zeros then at negative 4 plus minus 2i and 1/3. Whenever you can get to a 4th-degree polynomial, or sorry, 3rd-degree polynomial with 4 terms, I misspoke, go figure, do that. We got Bella. I don't know who wants to go first. I'm thinking of number 1 through 6.
12.
7.
12 and a half.
It was 4. You get to go. So leave. I guess next.
I guess.
Okay, so how do you know if it's an act?
X squared plus 4. If I get that, solve that for 0. Subtract 4, take the square root, and I get plus or minus 2i. Okay. Oh, I love 23. So 23 gives you multiplicity at negative 1. Therefore, your term is going to be x plus 1 quantity squared. Okay. On the other one, I have 1 minus 2i, so that means there also has to be 1 plus 2i. So I started as x minus the quantity, 1 minus 2i. And then x minus the quantity, 1 plus 2i. When I get to this part, I'm always going to distribute the negative into the 0th term. And then rewrite. So I'm going to get x minus 1 plus 2i. And then on the other side, I'm also going to have x minus 1 minus 2i. This sets up the pattern to be a squared minus b squared. This is a factored form of a difference of squares. This is a plus b, a minus b. So in order to FOIL this out, it's just going to be the first term squared minus the second term squared. Obviously, we still have this x plus 1 squared right up here. Okay. So what we do here is we FOIL out this. And to that, I have to subtract 4i squared. What's I squared? What's negative 4 times negative 1? 4. That's 4. So this becomes x squared minus 2x plus 5. And then I have to multiply that to x squared plus 2x plus 1. Hopefully we're not killing any puppies anymore. And then just FOIL out and you get a 4th degree polynomial. Okay. Yes. Good conversations.
What's an easy way to FOIL out 3?
Just one at a time. There's no easy. There's no pattern, there's no nothing. It's just multiplying. Okay? What else? Yes, sir.
47.
We have a question with Luke. Do we have to, can we just leave it like that?
No, you get FOIL out.
Oh.
I'm leaving like that because
Alright.
I can't.
Because he's a teacher, he said so.
Genius.
What number is it? 26.
Anyway, this one's you have plus minus 1 over 2. So that's hopefully we should be all right here. I have a 0 at -1, therefore my term will be x plus 1. And you can probably tell right away what I'm going to do next. I'm going to group it. So your other two terms are x squared plus 1 and 2x minus 1. Total zeros at -1 plus minus I and 1/2. Whenever you get to that 3rd degree polynomial with 4 terms, please look and see if you can group it. It makes your lives so much faster. Now, I know you weren't doing that. You see how much quicker it is? Go ahead and pass that up then. And let's talk about the last section here. I'm going to combine the parts of 6.8 and the parts of 6.9 that work together with everything we've been doing. There will be other parts of these two sections that we'll come back to towards the end of the school year that deal a little bit more with some of the modeling stuff that we will look at eventually. But for right now, we're going to keep it pretty straightforward. And what we're looking at in 6.8 is graphing via tails. Graphing via tails and zeros, similarly to what we did back in earlier.
Is this ridiculously easy?
No, not really. What's that? He's just trying to get me to say it's ridiculously easy, because I say that quite often. No, it's very simple. It's going to be written differently.
How many forms of polynomials?
How about just let me get going and we'll worry about it in a second here, all right? It's not trying to mess with you guys here. For example, if I'm looking at something like this, f of x is the quantity x minus 2, x plus 4, and I'm going to graph that via the end behavior and its zeros. Where are the zeros? And what are the tails doing? Good. And we just did this. All right? We would do that. All right? We don't know where this value was or anything like that. And when we went to polynomials with higher degree, we had to learn the dance moves. Down, up, down, up, down, down. Things like that.
Drop. Hey,
Yes, ma'am.
How do you know that it's going to be up?
X squared, leading term coefficients positive.
Oh, because there's, okay. You put
So if I look at it, in terms of a higher degree polynomial, what we're going to do here is we're going to write it out as, well, we have f of x equals 1/4 times the quantity x plus 2 times the quantity x minus 1 squared. which means that this, if you FOILed this out, you'd wind up with a third degree polynomial, and that would have at most 2 changes of direction. Remember how we talked about that, where your change of direction was 1 less your degree?
Wait, how would you FOIL that out? Would you FOIL it out and then use the exponent on
No, you do exponent first, and then you multiply.
If it was all in
Yes.
parentheses.
I would do x minus 1, then I'd multiply that by x plus 2, and then I'd multiply all that by a 4. So in this case here, what are my zeros?
-2 and positive.
Negative 2 and positive 1. What's special about the positive 1? Multiplicity. Also, since it's got multiplicity at positive 1, what happens at the graph at positive 1? It changes it right there. So we know that this direction, because that first term is a 4th, what direction is this going as far as the tails are? Down, up. So we know that this graph's going to look like this somehow, right? Because it's got to go through the zeros, and there's 2 changes of direction, right?
Oh, is it?
Cube.
Oh.
So what if there's
Because because you have 3 different zeros, then would not change direction on the split.
It still changes direction twice. If it's a
Not change direction.
because of the well, even the multiplicity changes direction here, and it changes direction here.
Yeah, and that's only 2 zeros. What if you have 3?
No. It's change direction is always 1 less your degree. We have 3 zeros here. One of them has multiplicity.
Yeah.
So you have 3 zeros.
What if you had 3, but
If you had 3 changes of direction,
Oh,
you'd
I
have
got you.
4th degree polynomial. Now, what we're going to look at today via the calculator is what's going to be called a localized, or what they call a relative maximum, or a local maximum, local minimum, or relative maximum, relative minimum. They mean the same thing. This value here is what we call a relative max. This here is a relative min, or a local min. What do you mean?
Like if it went up again, on the right, went up again, would you look at 2 curves?
Yes. You can look, yeah. Because you're looking at a specific section. Basically what you're looking at is what's called a point of inflection. The point of inflection is where it changes direction. And it changes direction is what they call the localized maximum, localized minimum, or they call it relative max, relative min. Relative max, local max means the exact same thing. Some texts use one, some use the other. Yes, ma'am?
Could there be more than one?
Yeah, that's what he was just asking. Yeah, absolutely. I mean, if you have, if you've got a 5th degree polynomial, you could have up to 4 changes of direction. So you could have 1, 2, 3, 4. So you could have 4 points of inflection. This, since it's a height, it's a high point, this would be a relative max, relative min, relative max, relative min. That's the way it would look. Okay. Your calculator does all of this for you. Yes, sir?
would we ever be doing anything like that? Where we would just kind of,
Meanders about?
yeah.
Pre-hop.
Okay, so you know how much was that quiz?
Uh-huh.
Are we gonna have to know everything that was on that quiz for the test?
Yeah. It's all chapter 6.
Oh
Yes, sir?
my goodness.
What if it's a right angle? Another right angle. The corners,
I don't think you're going to get that on the one shot. What's up?
What is it?
It's just where the change direction. That's just all it is. It's just where does it change direction? Where does it go from increasing to decreasing? It changes direction at that point.
Two things. One, why do we need to know these three calculations? What is that going to help us in a career?
Slopes, tangent lines, the average rate of change, all of this stuff.
Two, did we get a
They're in a pile. Yes, sir.
How do you find the value?
I'm getting there. If you guys stop worrying about everything that's bad, I'll get there. Take your calculator out. Go to your y equals. Go to your y equals, we were putting that function. I believe it was 1/4, correct?
Yeah.
Quickest way to type in 1/4 is to type 0.25. I rarely, if ever, use decimals, unless it's a decimal that's very easy to use in my calculator. And then it was what? I forgot.
X plus 2.
X plus 2.
Was it x plus 2?
Yes, and then x minus 1.
Quantity squared. Okay. Go to your graph. And you should see that. Okay? Which is good because it's third degree polynomial. You can have up to, third degree polynomial has up to 2 change directions. Now what we're going to do is we know that it changes direction at 1 because it had multiplicity. So your relative minimum would be at -1, 0. We also know that this point here, let me move this on here so I can show it. This point here, whatever this value is going to be our relative maximum. Well, in order to find the relative max, we just hit the button on the calculator that I lost my calculator at. Oh, there it is. I hit second, calculate, number 4, maximum. And what we're going to do is we're going to move our cursor. Remember how we did left bound, right bound?
Yep.
Move your cursor to the left of the max point. Move your cursor to the right. Yes, sir.
Is there a way we're going to find it?
Calculus.
0?
Actually, you'll do it pre-calc. It's very, very easy.
Wait, second calculate what?
Maximum.
Oh, maximum.
So in this case, I have a relative maximum at -1, 1. Yeah.
I got 0.999.
That just means that the parameters you chose are just a little bit wider than what I chose. You want to be as close to where it's changing as possible, and you can just round it out. If it's 0.99999, it means it's 1. Okay? Yes, sir. What do you mean? The whole window?
Yeah.
10 by 10. Go to window.
I keep on getting errors.
That's fine. You should be. Sorry. Okay? So that's how you're finding these. You're just hitting buttons on a calculator, guys. Let's try another one. Let's plot this one via the zeros, end behavior, and find relative maximums and relative minimums. We have f of x is -2 times quantity x squared minus 9 times x plus 4. We know that we have zeros where? 3, -3, -4. Very good. What are my tails doing? Up, down. Very good. First terms can be negative. Third degree polynomial can be up, down. So we're doing this. My points of inflection, my relative max, my relative min, don't line up with multiplicity, so it's going to be a little bit tougher to find. I actually have to press buttons on my calculator. So in order to find them, we just select the minimum here and find the maximum here. So back to your calculator. Y equals, clear out what you had. We have -2 parentheses x squared minus 9, and then it was x plus 4. Thank you. I thought. And we graph it. We don't see the maximum. Actually, if you look closely, let me show you. If you look closely, you might see it when you tilt it down.
Where?
Really?
You dummy.
That was awesome. Oh, it's even better. Oh, it's great. I love it. Every year I get somebody. Change your window. Obviously, I changed the Y value, so just change your window to see if you can find out where it changed. From earlier in the day, I remember someone said it was that if you change it to 100, it shows up nicely.
Shows up nicely at about 80.
That shows like good.
So you change your window. You guys will get accustomed to having to mess around with your windows quite often to find these values. It happens all the time, okay? And then you just go ahead and hit your second calculate, and then you're gonna find your minimum for the low value, the maximum for the high value. Second, trace, minimum's 3. Move my cursor over. We're getting there. See, I'm just getting it just to the left of it. Hit enter, move to the right of it. The closer your variance is, the better calculation you're going to get. I have a minimum at negative 3.52 and negative 3.25. There's my minimum. Always round to 2 decimal places, please. And do the same thing for the maximum. You're getting there. And 0.85 and 80.29. Which means I should probably move this curve over.
It's 80.29.
29, thank you. Should probably move this curve over so that it's occurring on the positive side. Okay. And that's what you're doing. That's all you're trying to do, guys. You're just trying to get an approximate of where it's changing. Yes, ma'am.
Okay, so it's approximately. Yeah, from Microsoft, it's like-
Well, I will be able to tell if you're using trace. Don't use trace. You have to calculate button because it'll bring in the primary perspective.
Well, if you're just looking at that,
Then you're just on that. It should be 0.85. It just follows through. Yes, sir.
I was under the impression that we're not going to be able to use our calculator on
There will be calculator and non-calculator.
that. We'll be on the same page.
Yep. Okay. So the other part of today that I wanted to look at is how do we come up with writing this exact formula. The stuff that's in 6.9 is how to write the polynomial function of in the third degree. What we're going to do is when I ask you to write out the function in the third degree, we're going to leave it in this format. The format looks like this. F of x is some value. Actually, we'll write it as y. So write it as y equals a x minus h, x minus k, and x minus l, where h, k, and l are zeros of y. They're the zeros of the function. So what I'm going to do is give you guys a graph, and you're going to write the equation of the graph. And it is, I almost did it. It is a lot of just direct substitution and solve for values. Okay? Let me show you the example that I have. I'm going back. So I'm going to have this graph. I have this graph here where I have zeros at -3, 2, and 5. My zeros are at -3, 2, and 5, which means my terms would be x plus 3, x minus 2, and x minus 5. And I still have this value of a and some value of y. A is your scalar multiplier that tells you how high things are going how skinny they're going, and what direction they're going for the dance. Okay. So if you look at this graph here, we also have one other point. It just so happens that it's the y-intercept. That has an ordered pair of 0 and negative 15. So if I have another set of ordered pair of 0 and negative 15, what could I do in relationship to the equation above it to find A?
Math.
Okay. Substitute in. You just substitute in that ordered pair and solve for A. Like I said, guys, this winds up being a lot of direct substitutions. What I'm going to do is take the negative 15, set it for y. I'm going to solve this equation for A using 0 as x. Oops, sorry. What's 3 times negative 2 times negative 5? 30. What's A? Negative half. It's not 2. You have to divide by 30. So your A value becomes negative 1/2. And now you can take that and put it in front of here. That's what you're doing. You're solving for that multiplier that's allowing you to see how fast, how skinny it's going to be, what direction the tail is going, just by using that. Yes, sir?
So we just find out all that information by plugging in a random point on the thing.
It's not a random point, it's whatever they're giving you.
So, okay.
It could be any point. It just so happened in that case, they're giving you the y-intercept. Sometimes they'll just give you some other point, but they have to give you 4. They'll give you 3 zeros and a 4th. You have to just distinguish which one's a 0, which one's a point.
That's hard.
So you're just putting in the x and y values for that point. And then
Yes, sir. Yep. Show you one more. Yeah, Marcy.
I feel like this is one of those situations simple novel. She's gonna be.
What's that?
I'm not sure it's this one.
Yeah, you can do that. And a lot of times, this is a good question. You asked, could it give you the relative max, relative min? Absolutely. Hopefully the numbers are clean though. Even though the numbers are ugly, you can still do it because you got a calculator. Oh. All right, so here's 4 ordered pairs. I'm going to write out the cubic function with those 4 ordered pairs. What are these things? So we're going to write it into the form. I don't think the book uses that generic formula, but it makes sense by H, K, and L. We used H's and K's for zeros before. I just added L.
Oh, man. That L is really vague.
If you want.
Ours are worse.
So obviously in this case, my first 3 are my zeros, because I have zeros for y. Yeah, because I said there, so that means if negative 3 comma 0, that means it's at negative 3 on the x-intercept. It's an x-intercept. So that means negative 3 is the 0. Okay. What's x minus 0? Oh, you all right? What's x minus 0? X. Okay. So when I go to the next value here, what do I substitute in? Negative 2 for x, and then So
He's putting going forward.
you have negative 2 times 1 times negative 7. What's your value of A?
3/14.
It's like pi.
Easy.
And then you just rewrite it down. Okay? So, yes, ma'am.
So, when we're writing this and it's x minus 0, could you just put it as?
Yeah, absolutely. That's what I did the second time around. So you just write it out and you're done. These problems. Forgot which ones I assigned. And write it down. Do those, please. 6.8. It'll be 16 through 22, graphing via zeros and end behavior, and then you're going to find the relative maximums, relative minimums. Yeah, this won't take long. And then on 6.9, you're going to write the equations for 18 through 22. Yes, sir?
When do we stop learning new things for this chapter at least, and then start reviewing it? Thursday before the test.
Probably the day before the test.
Well, I gave us a reminder.
He said he'd give it to us Wednesday.
Wednesday, yeah, I should have for you guys by tomorrow.
Can I take a look for this?
Yeah, I can imagine. I was funny, I had it all the time. No, we should have a little bit more. We have like a couple little things here and there. Little tight ends. No, not this.
Wait, no, wait.
I'm not assuming that.